So I'm going to just hop straight into it. Our goal today is to make sure that anytime we encounter a new line, we display next token is -1, next lexeme is EOF. Now this is going to cause a couple complications for us because one, our boundary condition is EOF. As you can see here, the boundary condition to the main processing loop is whether the next token is an EOF or not. And two, our system doesn't really detect new lines yet. We don't really detect new line characters. So what we're going to do first, and the very first thing we need to do, is to make sure we change this boundary condition. The first way we're going to change a boundary condition is by using the fact that a text file is the size of a text file is equivalent to the amount of characters that are in it. If you don't believe me, here's an example. This function I'm going to put in the description below. It is just a way of getting the size of a file. If this doesn't work out, then it returns false or returns -1, and that's your error state. But this is going to work. So as you can see, it prints out the contents of the file, hello, and prints out the size. Now you say, okay, well, there's a hello here, but this is only 6 characters. Where's the 7th? Now if we hop into this file, we see that there's not just hello here. We also have a new line character that's right here as well. This new line character is actually considered a character that's the same size as, say, an O, an L, an H, a period, any other character. It still has 1 byte. This is going to be incredibly important later when we actually get to detecting this. But for right now, what we're going to do is copy and paste this code into our grammar or into our parser. I can't spell today. Let me copy and paste the libraries. Just copy and paste all of them. There we go. We got the library. Let's create a global variable called int size. I'm gonna call this 0. Yeah. We could call an int, or we can call an oft. Either one works. Int or oft. Yeah, right here. Oft, if you didn't know, is an unsigned int. It's just a better way of being able, well, not just unsigned, but it's a unsigned longed int. So it's a better way of representing ints, especially when the file is huge and large and it goes past the boundary for how big an int can be in C. So we come down here where we are f size. We're gonna get, well, we're gonna open up the file, and if it succeeds, then we get the size of the file. So we're going to call this size is going to be equal to f size. Now keep in mind we already have a path variable that contains our file name. Here's where your file name would go. And let's just print the size to the screen. So file size is, now I'm going to use LD because it's a longed int. So L just stands for long. And we're just going to put the size here. Now, keep in mind, longed ints work just like ints. There's practically no difference. I don't even think you need to cast it when you assign it to an int, but really simple, no big deal there. So we can go ahead and print this out. File size 15. Now if you want to look at our file, this is what our file looks like. There are 15 characters here. No new line, but there's a new line here going to here. So there's only one new line in there. So what we need to do next is that we know we have this function called getChar, and getChar iterates through every single character in the file. We're going to compare how many times getChar iterates with the file size to be able to determine whether we're at the end of the file. So if getChar iterates more times, then the file size, then we realize, hey, look, we've reached the end of the file. We reached the absolute end of the file. So then we're going to come over here and actually assign a new variable called int iterations. You can call this whatever you want. Actually, probably something like get char iterations might be better, because we might need more iterations in the future. Who knows? We're going to go down to our function get char, and we're going to go here. We're going to go ahead here and increment at end of execution. So whenever you increment based on a function, based on the call of a function, you always increment at the very end. The reason why you do this, and the reason why this is extremely important, is because you want to make sure that you got to the end of the function, all the contents of the function except this one line has completed, and then you could go ahead and say that it's done. Because this is essentially saying that it's done. So we could say get char iterations is equal or plus plus. So this should increment it. Let's go down here, or go up here, and display the amount of times that we iterate through it. So printf, actually, it's probably smarter to just go ahead and grab this, put that there. Iterations. It's not a long D, but it's just a regular D. And we could just come here and set get char iterations, and then boom. So as you can see, this file size is 15 characters big, and we go through 16 iterations. So you might be thinking, okay, why do we go through 16 iterations? This doesn't make any sense. The reason why it makes perfect sense is because you don't know you're at the end of the file until you hit the end of the file. So the computers aren't like humans. They can't just look at it and be like, okay, we're done, right? Think of a computer going in blind. The computer's going completely blind, and it can only take what it sees right there, right then and there. There's no look ahead. It can only take what it sees right then and there. So it gets to the very end of the line. It can't see what's past it, so it just assumes maybe there's something past it. It doesn't make any assumptions, and it says, okay, maybe there's something past it. So it reaches past it, and it sees, okay, there's nothing there, therefore I must be at the end. Now, could there be something after it? Maybe. I don't know. There are some cases in which that assumption isn't a good assumption, but in this case, in our very simple case, it is. So what we can do now is come over here and make sure to only iterate if get char iterations is less than the size of the file. So as long as it's less than the size of the file, it's going to iterate through everything. So if you run this, look, it iterates through everything. Bada bing, bada boom. There we go. Now I'm going to end this right here because the next part is a little more involved, and it takes a lot of working through. So I'm actually going to have to draw things out and explain it to you guys. So I'm going to just stop this right here, and hopefully you learned how to deal with EOFs and be able to create a new boundary for your code. And this will feed directly into the next part. So see you then.